Hi, this is part 9 of my series on how to build your own Hopper 6502 computer. And I'm going to show you in this one doing something useful with that with the parallel port, right? And you can see I've missed a few pins, and and that's because those pins are used for other things. So the parallel port pins are used for the user button, I2C, and the built-in LED. But that's 4 out of 16, which leaves us another 12. And for this device, we've got 8 data lines and 3 control lines, so it uses 11. You can also run it in 4-bit mode, 4-bit parallel rather than 8-bit parallel. Let me just run it so you can see what it does. So I've taken some of my code from a while ago and written a driver for these Hitachi LCDs, and I just ported some C code to Hopper to make this work. Press Control C to break there. My C code is fairly generic. Let's go find it. Here we go. So you can decide whether it's going to be 8 bits or 4 bits. Your parallel interface. I've got it running on as the 8-bit mode right now. And you can also define the size of your screen. And the reason this matters is because this API was first created when they never really thought they were going to have more than 2 lines. So I've got this trick I use here, this LCD row start, so that when you write characters and it increments the position, it uses that this array to figure out the layout of the screen so that it knows, so that it can go to the next line easily. And in the initialization code, you can, so I've used it with 20 character by 4 character displays, and you can see the rows start at pretty weird conditions. Basically, it's always 2 rows, and they sort of fake 4 rows out of it. But the sort of most common one is the 16 by 2, where you only have the 2 rows like that. All right. While we're here, let's just show you. So yeah, I originally had this in C code that was running on Arduino. I made a sort of a very generic, very reusable library. But here it is ported into Hopper. And what's different about Hopper, let's put a breakpoint over here, is that unlike the Arduino code, it's really easy to debug. So you could press F5 and be there. And we're about to write out a character, so let's write a character. There it is. So it appeared on the screen here, and then if I press F5 again, I get another character, and another one, and another one. And while this is happening, if we look on the right here in the debugger, we can see our column 4, column 5, column 6, etc. And you could step even deeper into, like, what does write data do? So you click into write data. And it calls write data 8 bits. So let's go into there. And then that's calling digital write. And even that is not an API call yet. It's a Hopper function. And this is what digital write does. Converts the pin number to part of port A or port B, etc. And then this write byte is calling in. Anyhow, pretty generic driver, so that you could drive any of these screens, either in 4-bit parallel or 8-bit parallel, and don't really care how many rows or columns. It's configurable. So something useful you can do with your parallel port on your Hopper 6502 machine. Also, I specifically chose this one because it's the same LCD that comes in Ben Eater's kit. So if you started with his kit, because from that kit you'd get all 4 of the main chips for here are the same as Ben's kit as well. Anyway, you'd be able to use your same LCD here again, just for fun. Thank you for watching.